Hello, this is 4.6 exponential functions and applications. So objectives for this section is number 1, solving exponential equation using matching bases, and number 2, solving exponential equation without using matching bases, and applications. So solving exponential equation using matching bases, which means the exponential functions are always a one-to-one function, so two exponential expression with the same base are equal if and only if their exponents are equal. So which is when you have the b to the x equal to b to the y, as long as the both sides has the same base, as long as the x and y is equal, and then the values are equal. So following this data, the first step in our process to solving exponential equation will be to check if it is possible to write the equation as the equality of two exponential expressions with the same base. So since we have a same base, you can just set up the exponent equal each other, okay? So you pull it out. 3x minus 1 equal to 2, and then so for x. 3x equal to 3 divided by 3, x equal to 1. So that's the solution. These two sides not an equal base, but I can change the 9 as a 3 square. So 9 is a 3 squares of x plus 1. And then we can say 5x minus 4. And the other side as 2 and x plus 1, we can use the product rule, which means same as 2 times x plus 1. And then 5x minus 4, distribute the 2, solving for x, subtract 2 both sides, add 4 both sides, and then 3x equal to 6, divided by 3, x equal to 2. Okay, next problem. Well, we can change the 27 over 8 as same base as a 2/3, okay? Which is, we got 2/3 of x minus 1. But I know that 27 is 3 cubed, and the 8 is 2 cubed, and 2/3 to the x minus 1 power, and then this is 3 over 2 of third power. But still not the same base, so what you can do is, I put the 2/3 as x minus 1. Now, if you flip it inside of the base, and then it becomes negative third power. So now we match the base, so you can set up the exponents set equal to each other, and then solve for x. X equal to negative 2 for this answer. So solving exponential equation without using matching base. Okay, so that one we can do this. So once you have a space is not matching, we can actually change to the logarithmic equation to solve this, and then we just compute from here to here, because we are solving for x. And also, you can put the log or ln, any base you wanted on both sides, and then you can solve for x too, which is come out the same as at the end anyway. So when we solve the 7 to the 3x minus 1 power and equal to 49, the solution was found to be is x equal to 1, because 49 we can change to the 7 square. But now we're going to consider that 7 to the 3x minus 1 equal to 61, but there's no way we can change the 61 as 7 to the power. So all things identical except for the slight increase of the 49 to 61. Educated a guess for the solution to this equation is number a little larger than 1. So, but in this time we can do this. So you can do two ways, okay? So, but we can change to the logarithmic form. So exponents equal to the log, which is the base 7 of 61. And then you can just solve for x. Do not use calculator, please, okay? So add 1 both sides first. So 3x equal to, but this 1 I'm going to put in front of the log, because if you put the other side of the log, and then you might think that it's added to the 61 to the 1. You can't do that. And then divide by 3. So you can just whole things divide by 3, which is x is, so 1/3 of 1 plus log, but you can put a 61 over log of 7. Yeah, so that's the, and then you can just approximate it. So if I approximate it, which is 1/3 of, and the 1 plus, and then the log of 61 divided by log of 7. Then I got about 1.04. Well, another way is you just need to put the log on ln both sides. I put the ln. So ln of 7 to the 3x minus 1 equal to ln of 61. So once you change the to that, and then you can pull out the 3x minus 1 is equal to the, of, which is, we didn't learn this rule yet though. So this is actually the first one is the best way. And then we got ln 7 equal to ln 61. So, and then what? And then divide by ln 7 both sides. And then we got 3x minus 1 equal to ln 61 divided by ln 7. And then the same thing, add 1 both sides. So which is 3x equal to 1 plus ln 61 over ln 7. And divide by 3, which is the same as times by 1/3. So x equal to that, which is the same thing, isn't it? So you got the answer of 1.04. But I put the log for this one. Alright, so general process for the solving exponential equation. Number 1, isolate the exponential expression. Number 2, if the equation can be written as a b to the x equal to b to the y, we just need to set the x equal to y and solve. Otherwise, take a log on both sides, either the natural log, ln, or common log, log, log. Use the power of the logarithm to bring down the exponents and solve for the variable. But the thing is, we haven't learned that yet, okay? Alright, so solve for x. So add 5 both sides. So 4, 2x minus 1 equal to 26. So we have a different base. So this time, well, we're just solving for the exponents, right? So 2x minus 1 is the log. Now the base is a 4 of 26. Now 2x minus 1, you can change the log of 26 over log of 4. And then add 1 both sides. And then you got 2x is 1 plus log of 26 over log of 4. And then divide by 2, which is divide by 2, same as x equal to 1/2 of 1 plus log of 26 over log of 4. So as an expression, you can simplify, but we can just compute using calculator. So 1 plus of divide log of 26 divided by log of 4. Then I got about 1.68. It's approximation, okay? Alright, the letter B. Same thing too, okay? So what I do is exponents is equal to the log base 10 of 91. But the good thing is base 10 is the same as a what? The log, isn't it? So I can just put the log of 91. Subtract 1 both sides, which is 3x equal to negative 1 plus the log of 91. And then divide by 3. And then I get x is 1/3 of negative 1 plus log of 91. And then you can just approximate. So 1 divided by 3 of negative 1 plus log of 91. I got 0.32. Alright, next page please. Now see, first of all, we are solving for x, so I just need to divide by 200 both sides because this is a factor. And then you got cancellation. 30 is e to the 0.05x. Now, since the base is e, I'm going to put the ln both sides this time. So ln e to the 0.05x. And then ln 30, but the ln e to that is the same as 0.05x. Okay, because ln e to the x, same as x. So for x means divide by 0.05 both sides. And then x equal to. Okay, so ln 30 and divide by 0.05. I have 68.02. Okay, this one, well, this time, okay, there's no other choice, okay? So I need to put the log or ln both sides. Let's put the log this time. So log of 3, 2x minus 5. And then log base 4, log of 4, x plus 1. Now, your exponent is 2x minus 1 to 5. You can pull it out. And then you can pull out the x plus 1 log of 4. And then you can divide by log this time, okay? So this time, we need to open up the grouping by multiplication. So I got 2x log of 3 minus 5 log of 3. x times log of 4 plus 1 times log of 4. But we are solving for x, so I'm going to put all the x term of the log on one side. And then I'm going to move all the term doesn't have x term on the other side. So this cancels out and this cancels out. Now we got 2x of log of 3 minus x log of 4, which is log of 4 plus 5 times log of 3. And then in order to solving for x, one way is we factor it out. So we got 2 log of 3 minus log of 4, which equal to log of 4 plus 5 log of 3. And then we divide by 2 log of 3 minus log of 4 both sides. 2 log of 3 minus log of 4. And then we just need to use a calculator to make sure that you need to put it in the parentheses, okay? So parentheses of log of 4 plus 5 log of 3 divide by parentheses 2 log of 3 and subtract log of 4. And then I have 8.48 as approximation, okay? So next page, please. Application. The last component of this section will introduce a few examples of the many applications that involve the exponential equations. So example 4. How long would it take to double an investment in an account earning 5% compounded daily? So we have to use a compounded periodically formula, which is I put right here. But this time, how long to figure it out, so which is we're looking for years, okay? So, but it says a double, right? So which means whatever you put the P amount, you need to get a doubles amount. So we don't know how much you put it in. So I can say we make a doubles of principal, which is from the principal, right? And then we got 1 plus, but the rate is 0.05 of the daily, which is 365. And then 365 and then times by t. We're looking for t this time. And then if you divide by p both sides, because p is not going to be a 0, we got 2 a's of 1 plus 0.05 365 to the 365t. So same thing. Now what I do, we're solving for the exponents. Your exponent is 365t. The log of base is 1 plus 0.05 over 365 and then of the 2. And then divide by 365 both sides. And then your answer will be, this will be, right? And then 1 over 365. And then you just put it as log of 2 over log of 1 plus 0.05 over 365. And then you can just use a calculator. So 1 divided by parenthesis 365 parenthesis close parenthesis open, and then the log of 2 divided by log of 1 plus 0.05 divided by 365. And then all say, oh my goodness, is it? This not be possible answer. Okay, hold on, let me try it again. So 1 over 365 multiplied by log of 2 divided by log of 1 plus 0.05 divided by 365. Yes, that's better. So I got 13.9, which is about 14 years. Okay? And example 5. How long would it take for 500 to grow to the 750 in an account earning 6% compounded continuously? So I give you the compound interest, continuous compound interest formula, okay? So amount is 750 from the 500 e to the 0.6% to the t years, okay? So divide by 500. So you can reduce if you wanted it. So 0 cancel, 5 goes, I think it's a 25, right? So 20, is it 2 and 3? So you got 3 over 2, which is e to the 0.060. Since the base is the e, I put the ln this side. ln e of 0.060. And then ln 3 over 2, same as 0.06t. And divide by 0.06 both sides. And then give us a t is ln of 3 over 2 divided by 0.06. I got 6.8. So about the 6.8 years. Or you can just say about 7 years too. So for the next example, we are again ask a question about the saving money. But this time using the formula of the P times, that kind of formula we have. So this formula represents the money typical way most individuals save money, putting the little money away at a specific time interval using every paycheck. Usually every paycheck, using all the same letter as a compounding interest. Only variable with a slight conceptual change is a P, which now represent the amount of money entered into the saving and each time interval rather than a one-time investment. So example 6, because if you got paycheck, you might want to take the like a 10% off, 10% of the whatever paycheck and then put as a saving. But you just don't want to just put that as a simple interest. You might want to put that as something that give you the more money, right? So example 6. Suppose you have a $50 every 2-week paycheck put into a 401k with a company matching of the $50. Assuming a 7% rate of the return, answer the following questions. So what will be your balance after 5 years? So looking for the balance of that, the principal is 100. Every 2 weeks. So what will be a balance? Okay. Hold on a second. So I want to say make that as 200. Let me put down as a 200 because I want to make the monthly, okay? Because n is a 12 this time, right? Instead of 24. So we have 1 plus 7% for the monthly, subtract 1 over 0.07 over 12. And then that give us the amount for NT, sorry about that, 12 to the times by 5, okay? All right, so 200 times by, okay, another one. So 1 plus 0.07 divided by 12 and head of 12 times 5. Subtract 1, close, and divide by 0.07 divided by, parenthesis, 0.07 divided by 12. It give us a, wow, that's a lot. Okay, so you get, in 5 years, you get the $14,318.58 from the 200 monthly. What will be your balance after 10 years this time? Okay, so same thing. So A of 200 for monthly, 1 plus 0.07 for 12, but 12 times for 10 years, okay, minus 1 over 0.07 for 12. So same thing, but I changed into the, so 200 times 1 plus 0.07 divided by 12, and then powers of 12 times 10, subtract 1, and divide by 0.07 divided by 12. Okay, so I get 34,000 $616.96. So even though from 5 years is about 14,000, and then 10 years it's only 5 years later, but it's more than double, right? Yeah. What will be the balance after 20 years? Oh, so now we change the 20. So A equal to 200. 1 plus 0.07, 12 head of 12 times 20 minus 1 over 0.07 over 12. Okay, make sure you need to use the parenthesis properly, okay? So 200 times, okay, let me go, okay, I don't think I can go back. 1 plus 0.07 divided by 12, head up, 12 times 20, subtract 1, divide by 0.07 divided by 12. Wow, pretty good. 104,000, wow, $185.33. See that? But 7% is a pretty good interest rate, okay? All right. The next page, this calculation shows the powerful effect that time has when developing a long-term saving plan. When planning for the retirement, starting a plan early in time can substantial benefits. Not every example involving exponential equations must revolve around money. There are models in many areas of the study that follows exponential patterns. For next example, we will be considering the chemistry example involving the radioactive carbon-14, a compound that used to determine the age of the Asian artifacts. Similar to the example of the continuously compound interest, radioactive decay of the substantial following of the model of this. Okay, so A is the amount present at the time, and then A sub 0 is the initial amount that's starting with. K is a constant decay with depends on the substance involving K is less than 0, which is that's what we're using here because of decay. And then also the constant growth with depends on the substance involved the K greater than 0. And T is the time. Using the fact that the half-time of the carbon-14 is 5,730 years, determine the constant decay of the carbon-14. Okay? Alright, so half-time, which is, well, there's actually the formula for the half-time. So we are looking for the constant decay, which is R. So R is the ln 2 of t. So ln 2 divided by 5,730. And the rate is really, really small, almost a 0. It's going to be the 0.00012, which means it will be 12, so 0.012%. Using the constant K, find how long it takes the 10 gram of the carbon-14 to decay to only 3 grams. So 3 grams remains, right? So, yeah, so you can say 3 grams left from the 10 and e to the K. Oh, we use the same, we using the constant K, right? So this is a K is 0.00012 to the T. We're looking for time, the years, okay? Alright, so divide by 10 both sides. You got 3/10 of the e to the 0.00012 T. Of course, ln is better for this one. 0.00012 T. And then 3/10 of 0.00012 T. And then so for T is 0. Divided by 1 to both sides. 0.012. And then T equal to, and then use your calculator. So ln of 3/10 divided by 0.00012. It can be negative. That's kind of weird thing too. No. Did I mess up something? So, oh yeah, k must be negative. What am I saying? K is a negative. Sorry about that. K is a negative. We divide by negative. What am I talking about? Sorry about that. K is a negative because it's decay. Okay, that's why we got negative years. Okay, that's weird. Okay, so when you divide it, sorry, I'll do it. ln 3/10 and divide by negative 0.00012 give us, oh my goodness, 10033 years. Okay, they're pretty long years, right? Okay, all right, so that's all. Thank you for listening.